Hello everyone, welcome to Reactive Labs. Today we will learn about Apache Spark. Apache Spark. So what is Apache Spark? Why do we need Apache Spark? What what's something that could not be done without Apache Spark? It's real-time recommendation. Actually real-time processing and recommendation. So this is something which Spark helps us achieve. So if you have not watched my MapReduce video, please go and watch that because Spark is similar to MapReduce but with advanced capabilities. Okay, so just like in the MapReduce, we have one step map and other step as reduce. Spark more or less also has the same thing. First step is map and second step is reduce. So let's take an example to understand it better. Netflix. So imagine Netflix wants to recommend you shows, what shows you would like by looking at what everyone else is watching. But this time, let's say in earlier case, like MapReduce case, what happened was it broke down the data into chunks, used the keywords, hashtags to understand, as I explained in the MapReduce video. So, and later it would just take the count and whatever count is maximum, it will just recommend it, right? Something like that happened. But that was just a counting, nothing else. So Apache Spark can do much more than counting. Okay. And Apache Spark can do all these things in real time. MapReduce is mostly for batch processing. So it's not in real time. It's mostly done offline. Okay. So yeah, Netflix example. So this time Netflix wants to do it even faster and handle even more complicated tasks rather than just adding and showing what was the most popular search or hashtag. So again, it will come to the map stage, and just like MapReduce, Netflix starts by breaking the data into smaller pieces. They have a huge amount of data, right? Because it has millions and billions of users, hundreds of millions of users. So they have huge amount of data, like what people watched, when they watched it, how long they watched it. They give each piece of data to different computers to process. These computers might look at different things like how many times a certain show was watched or which shows people usually watch together, right? So even MapReduce's map phase did the same thing. But here is where Spark's different. Instead of just doing one simple task like adding and then moving on to next task, Spark lets these computers do many tasks at once, which are mostly in memory, right? So in memory is basically super fast short-term storage. In memory, whenever we use the term in memory, we should consider two things. First is it will be super fast, and second, it is a volatile memory, means it will be lost, right? It's a temporary storage, right? Then this is what Spark does in map stage. For example, one computer might be looking at show ratings while another is figuring out the most popular genres, right? This makes everything much faster. And then when it comes to the reduce stage, what happens is once all the computers have finished their task, Spark quickly combines these results. But Spark can do more than just adding up the numbers, which MapReduce did. It can also do more complex things like predicting what shows you might like based on the patterns it finds in the data. Just like real-time recommendation engine, right? It requires a lot of processing. So in this example, map is when Netflix uses Spark to break down the viewing data and process different parts of it very quickly, handling many tasks at once. And reduce is when Spark combines all the processed data, but it can also do more advanced things like making smart recommendations based on what it learned from the data. So the big difference between Spark and MapReduce is that Spark is much faster and more powerful. So it enables systems like Netflix, YouTube to give you better recommendations in less time, right? Even if they are looking at a lot of complicated data. So I hope this gives you a good understanding of why Apache Spark is needed or why it was needed. What was the problem that MapReduce could not solve? Or what was the problem that MapReduce could solve but could not do it fast enough? Right? That's why Apache Spark is needed. So let's start with the introduction of the Spark. So Apache Spark is a powerful distributed computing framework that provides fast in-memory data processing capabilities. Okay. So basically it's a powerful distributed computing framework. Powerful distributed computing framework that provides fast in-memory data processing capabilities. Fast in-memory data processing capabilities. It is designed to be highly scalable and fault tolerant, making it suitable for processing large datasets across clusters of computers. Spark supports various types of data processing, including batch processing, interactive queries, streaming data, and machine learning. Its core strength lies in its ability to perform in-memory computations, which significantly reduces the time required for data processing tasks compared to traditional disk-based processing frameworks like Hadoop MapReduce, Hadoop HDFS, which we discussed in the last video. So, in short, Apache Spark is an open source unified analytics engine designed for large scale data processing and analytics. It's known for its speed, ease of use, and ability to handle a wide variety of data processing tasks from batch processing to real time processing. Now, let's talk about the components of Spark. So, first is Spark Core. Second is Spark SQL or Spark SQL. Next is Spark Streaming. After that, mlib. And next is GraphX. Okay. So, what is Spark Core? Let's talk about Spark Core first. So, it's the fundamental component of Apache Spark, which provides the basic functionalities for task scheduling, memory management, and fault tolerance. It manages the execution of tasks across the cluster. It handles in-memory data storage and management, and it ensures reliable execution by recovering from failures. For example, Spark Core is responsible for executing operations like map and reduce on distributed datasets. Okay. Next comes Spark SQL. So it's a module for structured data processing, allowing users to execute SQL queries on data and perform data manipulation and aggregation. It executes SQL queries and integrates with data sources. It provides a higher level API for working with structured data. Spark SQL can be used to run SQL queries on data stored in a data frame or a table in a Hive warehouse. Okay. Next is Spark Streaming. So Spark Streaming enables real-time data processing by dividing the data streams into micro batches for processing. It processes live data streams in near real time. It works with sources like Kafka, Flume, and socket streams. For example, Spark Streaming can be used to process log data from a web server and perform real-time analytics. Next is mlib. mlib is a library for scalable machine learning algorithms, providing tools for classification, regression, clustering, and more. It implements machine learning algorithms for large-scale data processing. It facilitates building and tuning machine learning models. For example, mlib can be used to build a recommendation engine by applying collaborative filtering techniques. And in the end, GraphX. GraphX is a library for graph processing and analytics, allowing users to perform computations on graphs and perform graph parallel computations. It provides APIs for creating, processing, and analyzing graph structures. It implements algorithms for graph analytics such as PageRank algorithm and connected components algorithm. Graphics can be used to analyze social networks and find influential nodes. This is one example of graphics. Next, we will first change the color and then we will discuss the architecture. So first thing will be Spark applications. Spark applications are the programs written using Spark's API. Each application consists of a driver program and executors. So driver program coordinates the execution of tasks and maintains the application state. And executors run tasks and store data for the application. For example, a data analysis application might consist of a driver program which submits a job to Spark and executors which will perform the computations on the data. Next is RDDs. RDD as in resilient distributed dataset. Resilient distributed dataset. So RDD is the fundamental data structure in Spark, representing a distributed collection of objects that can be processed in parallel. RDDs are immutable, means once created, it cannot be modified, and they are fault tolerant. It means they use lineage information to recompute lost data in case of failure. For example, an RDD representing a data set of user transactions can be transformed and processed using operations like map and filter. Next is data frames and data sets. Data frames and data sets. So data frames and data sets are higher level abstractions built on top of RDDs, providing a more user-friendly API for working with structured data. Data frames are tables of data with named columns, similar to a table in relational database. And data sets are type-safe, object-oriented APIs for working with structured data, available in Scala and Java. For example, a data frame representing sales data can be queried using SQL-like syntax and transformed into a dataset for type-safe operations. Next is cluster manager. Cluster manager manages resources and schedules tasks on a cluster. Spark can work with various cluster managers including Yarn, Mesos, and its own standalone cluster manager. Uh, it allocates resources to Spark applications and schedules and manages task execution across the cluster. For example, Yarn can be used as a cluster manager to allocate resources and manage Spark applications in a Hadoop ecosystem. And last is Spark context. So Spark context is the entry point for Spark functionality, which allows the user to create RDDs, data frames, and perform operations. It initializes the Spark application and connects to the cluster. It manages the resources and configuration of the Spark application. Right? The Spark context is used to initialize a Spark session and submit jobs for execution. Now let's see the operations. So first is batch processing. Uh, Batch processing, as you know, processing in batches. I have made a separate full video on this. If you have not watched that, please go and watch it. In this, the processing of large volumes of data is done in batches. Spark executes batch jobs that process data stored in HDFS, Amazon S3, or other storage systems. For an example, a retail company might use Spark for batch processing of sales data to generate daily reports. Next is real-time streaming. Real-time streaming, again, I have made a separate video on stream processing. If you have not watched that, please go watch that as well. It contains a lot of details. So it processes data streams in real time by dividing them into micro batches. Spark streaming handles continuous data streams and processes them in near real time. A social media analytics tool might use Spark streaming to process and analyze user interactions as they occur. Next is interactive queries. So execute ad hoc queries on large datasets using Spark SQL. It provides an interactive interface for exploring data. For example, a data analyst might use Spark SQL to run queries on big data to gain insights and generate reports. Next is machine learning. Uh, Machine learning, we all know what it is. It builds and trains machine learning models on large datasets using MLib, provides algorithms and tools for classification, regression, clustering, and a lot of things. As an example, an e-commerce platform might use MLib to build a recommendation system based on user behavior and preferences. And graph processing. Spark performs computations and analysis on graph structures using GraphX, as we discussed earlier. It provides algorithms and tools for working with graph data. For example, a network security system might use GraphX to analyze network traffic and detect anomalies. So, what are the advantages of Spark? First and foremost is speed. Spark's in-memory processing capabilities enable faster data processing compared to disk-based processing systems like Hadoop MapReduce. Next is flexibility. It supports a variety of data processing tasks, including batch processing, stream processing, SQL queries, and machine learning. Next is ease of use. It provides high-level APIs in multiple languages, example Scala, Java, Python, R, and integrates with various data sources and systems. Next is scalability. It easily scales horizontally by adding more nodes to the cluster, handling large-scale data processing efficiently. Next, what are the challenges associated with Spark? So first is resource management. It requires careful resource management and tuning to optimize performance and handle large workloads. Next is complexity. Spark can be complex to set up and manage, especially in large scale or multi-tenant environments. Memory consumption. In-memory processing can lead to high memory usage, necessitating proper memory management and optimization. And dependency management. Managing dependencies and ensuring compatibility with different libraries and frameworks can be challenging. So, in the end, let's talk about the use cases of Spark. So, first is data warehousing. It stores and processes large volumes of structured and semi-structured data for analytics and reporting. As an example, a financial institution might use Spark to process and analyze transaction data stored in a data warehouse to generate insights for decision making. Next is real-time analytics. So it can analyze and act on data as it is ingested in real time. Again, for example, an online retail company might use Spark streaming to monitor and analyze customer interactions and transactions in real time, providing immediate recommendations and insights. Next is machine learning and data mining. Spark can apply machine learning algorithms and data mining techniques to large data sets to extract insights and build predictive models. For example, a healthcare provider uses Spark MLib to build models that predicts patient outcomes and optimize treatment plans based on the historical data of the patient. And next is ETL. Extract, transform, load. Perform ETL tasks to extract data from various sources, transform it into a usable format, and load it into a data repository. For example, a telecommunications company uses Spark for ETL processes to extract data from multiple sources and transform it for analysis and loading into a data lake. Okay, so that's all there was about Spark. I hope this video gives you a good understanding of Spark. In the stream processing video, I had mentioned that I would talk in more details about MapReduce and Apache Spark in later videos. So these were the two videos for that, this one and the one posted just before this. So thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.